Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be going through the quadratic formula. So a little bit of context, what is the quadratic formula for? Well, it is one of the ways that we can solve quadratic equations. So you've actually got 4 different ways generally that we like to use in GCSE. The main one, the one you kind of tend to go for initially, is factorising. That's when you put it into 2 brackets. But not all quadratics can be factorised. Sometimes it's impossible to factorise them. That's when I would then skip to the quadratic formula. If I can't factorise a quadratic, I will have to solve it by quadratic formula ideally. The other methods are obviously you can solve it graphically. That's when, let's say, you've been given it in front of you, you can physically see it and you go, oh yeah, here are my solutions here and here. Now, normally, we only solve quadratics graphically if the question has told you to do so. It should be very obvious. They'll have probably made you draw it already, or they'll say, using the graph, solve the quadratic equation. It will be very obvious. So graphically is kind of its own category. You're not going to use that method unless they actually tell you to. You can also technically solve quadratic equations by completing the square as well. They might ask you to do that in a question, or you could just do it yourself if you wanted to, but I feel like most people don't tend to use that method. It's not as common. So our main 2 are either we factorise, so put it into double brackets, or if you cannot factorise, you use the quadratic formula. The other thing to note though is that you can use the quadratic formula to solve any quadratic. So even quadratics that you can factorise, you can also use the quadratic formula. If they haven't specified in the question how to solve it, and let's say you have a calculator, you can always use the quadratic formula if you want instead of factorising. That's also fine. But generally, we stick to quadratic formula when you can't factorise it. Or maybe when it just feels like a really difficult one to factorise, so you just think, yeah, I'll just chuck it in the calculator instead. So that's our context, but mostly it's either factorising or quadratic formula. So here is our quadratic formula. You don't necessarily have to memorise it because it should be on your formula sheet, but just so you can see it in this video. Obviously, this is an example of a quadratic equation. We've got something x squared plus something x plus something equals 0. In order to use the quadratic formula, and also same if you're going to be factorising, you have to make sure all the terms are on one side of the equation and there's a 0 on the other. And then you just take the coefficients and substitute them into this formula. Now, I've put plus here. It obviously could also be a negative number as well. That's fine. So our quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Now the plus minus is there because with quadratics we always get 2 solutions, don't we? Think about factorising. There's 2 brackets. 2 solutions. So you're going to substitute it in, and the first time in your calculator you're going to put plus, write down your answer, and then if you just go back with your back arrow, on your calculator put minus instead, there's your second solution. So don't forget the plus or minus. So that's one of my tips. Another thing to note is that if your coefficients are a negative, you also have to substitute in the negative to the quadratic formula. It's not just the number. If it's positive, substitute it in as positive. If it's negative, substitute it in as negative. Now that is then something to be aware of because particularly here for the negative b, if your b coefficient is already negative, then that's a double negative. Okay, so technically you're substituting in b as a negative and then it's also a negative in the formula, so it's a double negative. So don't think, oh, well, there's already a negative in the formula, so I don't need to use the negative that's in my equation. Yeah, you do. You still need to substitute in the negative. It just then becomes positive. Now, that probably doesn't make a lot of sense without actually showing you an example. So obviously, we will go through some examples where I'll point it out. And these 2 pieces here are another key bit because sometimes when you try to solve with a quadratic formula, I'm hoping that the newer calculators are actually better, but I know that with the older calculators, sometimes you would end up with math error on your calculator. And it's helpful to know why that is. That is because, in terms of maths, just generally, you cannot square root a negative number. That's not specifically related to this, that's just in general, isn't it? You cannot square root a negative number. Let's just do a random one, right? -5. Do you see how I've got math error? That's what I mean. If you get math error, when you type in your quadratic formula, usually the problem is obviously therefore with whatever is inside the square root symbol. Because sometimes, if, as we said, if b is a negative, let's say it was -5, you're squaring it, sometimes the calculator will go, yeah, I know that when I square a negative, it becomes positive. Perfect. Sometimes it doesn't, and it just keeps it negative, which is incorrect. So just double check. Newer calculators might actually be fine in this case. They might not do that. But do double check. If I end up with a math error, just go back and have a little look at what's in the square root and just say, well, sometimes I just kind of calculate it myself. I just sub in the numbers. For example, -5 squared is 25, isn't it? So I might just sub in 25 directly, that type of thing. So a few tips there, but let's actually practice it so you can actually see what I'm talking about. As you can see, I will have the formula in this top right hand corner of each of the pages anyway. So you might just get a straightforward question like this. Solve 7x squared plus 2x minus 4 equals 0. Okay, initially looking at that, you're going, yep, it's a quadratic. Okay, in your head, you're kind of thinking, am I going to factorize? Am I going to use a graph? Am I going to use completing square quadratic formula? You're kind of thinking those things. So you're not going to use a graph unless they tell you to. Nothing here has told us to use a graph, so ignore that. The key for me is that it says give your solutions correct to 3 significant figures. Or maybe a certain number of decimal places. That to me kind of hints that obviously my answer is going to probably be a load of decimals. And if my answer is a load of decimals, it's unlikely to be factorized. So in my head, I just kind of put 2 and 2 together and I go, oh, okay, yeah, it's probably quadratic formula. Now, you might try and factorize that and then realize that you can't factorize it, and then you'll go, oh, okay, quadratic formula. That's also fine. But I think this piece of information here is quite handy. How do I give my answer? Oh, it's a format that's probably not likely to be from factorizing. So I would just go straight ahead and try and substitute in the numbers. So our a coefficient, it just goes in order, right? This is a here, so 7. Our b coefficient is the number in front of the x term, so that's +2. And lastly, c is just the number at the end. Now, do you see how c is actually -4? So that's what I was saying before. If you do have negative coefficients or negative numbers here, we're including the negative. All I need to do now, though, is do write it down just so that they can see you're working, is just substitute those numbers in. So -b, so -2, plus or minus, to get my 2 solutions. b squared, so 2 squared, minus 4 times a, which is 7, times c, which is -4, over 2 times a, which is 7. So you can just go straight ahead and sub that in. Sometimes I work out some of it myself. For example, this bit here, I know that there's a double negative, so that will become positive. So I might just put the positive in for myself, that type of thing. You can work out bits of it yourself if you want, but you don't necessarily have to. So this was obviously a calculated question because they did ask for 3 significant figures at the end. So you can see I've typed it in. I'm going to start with the positive one first. You can't really see that there, but I've used the positive one because it's either plus or minus. So this is my first solution. Obviously, because I want it as 3 significant figures though, you press your SD button, it will convert it. So now I can round it. 0.626 would be 3 significant figures. 0.626, that's my first solution. But remember, quadratics always have 2. So don't rewrite all of this back in, just use your arrow and just scroll along until you get to that plus here. Change it for a minus to get my second solution. Obviously that looks similar, but when I look at it as a decimal, I've now got negative 0.912 to 3 significant figures. 0.912. So there are my 2 solutions, correct to 3 significant figures, and you can see that I would never have been able to factorize that. They're definitely not whole numbers, they're not even nice fractions, are they? So that's the kind of most straightforward type of question they could give you. My next question is very similar. The only thing that's changed is now our b term is negative. So I just want to show you that particularly more than the fact that it's a different question. So you've got a is 2, b is not just 9, but it is actually -9. And c is also a negative, c is -14. So a, b and c, now I just chuck it into my equation. So negative, because that's from the formula, but then do you see how I'm subbing in -9, so it's a double negative. Plus or minus the square root of b squared, now this is also my other issue, is -9 squared. Subtract 4ac, so 4 times 2 times -14. So many double negatives here basically. We've got 3 double negatives so far. over 2 times a. Now, you can sub it in as it is like that if you want. Hopefully the newer calculators will cope with it fine. But the way that I would probably do it is I kind of semi-work it out. So for example, I'm not going to type in negative 9. Negative 9 is just 9, isn't it? It becomes positive. So I'm just going to type in positive. Then I'm not going to type in negative 9 squared because I know that when I square a negative number, it becomes positive. So either type in just 9 squared to avoid any errors with squaring a negative, or I might even just put 81 because I know that 9 squared is 81, but that's up to you. And then technically this bit, we can sub it in as we did in the previous question, or because I know, again, that that's a double negative, I could put just plus 4 times 2 times 14. That's up to you. It depends how much of that you understand as to what I've done there. You can work out as much of it or as little of it as you want. You could even work out, obviously this bit is 2 times 2, which is 4. You could work that out as well. But either way, I've just done this because I don't want to risk my calculator messing up any of the negatives. So that's the only reason. As you can see, I've not been given a math error, so that's good. So my first solution, again, 3 significant figures, is 5.72 for the positive version, as in the version where I put plus. Then just go back, just press your back arrow, and here, in between the square root and the first number, make it the minus version, and then I get negative 1.22. And those are my 2 solutions to 3 significant figures. So that was just me demonstrating how I would try and avoid a math error. Or if you get a math error, you can go back and kind of work around the negatives. But hopefully your calculator won't give you a math error anyway. Hopefully it's kind of smart enough to know what to do at this point. But as I said, if you get a math error, just pay attention to this bit here. It's going to be a problem with something in the square root. That's the problem. So at least you've narrowed it down if you do get that issue. Okay, so now we've got a different question worded slightly differently. So we've got here, solve x plus 3 squared equals 5, which, first of all, if you kind of imagine expanding that, hopefully you can see that that would be some kind of quadratic there, because I'm going to end up squaring the x, aren't I? So I know, just looking at that equation, okay, that's probably going to be a quadratic equation. And then my other thing that I'm picking up on is the next part again, with what format am I leaving my answer in? So give your answer in the form p plus or minus the square root of q, where p and q are integers. So first of all, I'm thinking, yeah, it's a quadratic. Okay, again, am I factorising? Am I using quadratic formula? Okay, because they've told me to give my answer in this format, there's no way that a square root comes out of factorising, is there? You don't get a square root when you factorise. So do you see how I'm kind of skipping past the factorising possibility? And I'm thinking, oh, okay, I'm going to use my quadratic formula. Also because I know, first of all, my quadratic formula has a plus or minus in it, and second of all, it has a square root symbol. So I'm probably going to use my quadratic formula. Now, technically, with this question, you could complete the square and get the same answer, because they haven't said that you have to use the quadratic formula, right? They haven't actually said that. So technically, if you prefer, you could use completing the square to solve this. That's fine, you could do that. You might think that that's kind of easier, that might be more straightforward to you. Or you might not like to complete the square, in which case use the quadratic formula. Sometimes there are options really, but if you want to go through how to solve quadratics by completing the square, I will link the video down below. But I'm going to kind of go at this one, obviously, with the thought process of using the quadratic formula. So in order to use the quadratic formula, we obviously need to know what is a, b, and c. But currently, my equation is not in that format, is it? So I need to expand and simplify everything and move all of the terms to one side of the equation. So first of all, expanding it, this is double brackets basically, isn't it? So expand that, we get x squared plus 6x, I'm just going to whiz through it, plus 9 is equal to 5. And, as I said at the start, you need to have everything on one side. So let's move the 5 across. So plus 6x plus 4 equals 0. Now also, you could also try and factorise it, but if you have a look, it's impossible. So I'm going to use the quadratic formula. And again, just match up the letters with the numbers. A, in this case, do you see how there's technically no coefficient, which means that A is 1, because obviously it's not 0. It is a number, it's just not really shown. That's A. B, this time, luckily, is a positive, so 6. And C is also positive, so 4. And from this point, we're just carrying on as we did before. So minus 6 plus or minus square root of 6 squared minus 4 times 1. Technically don't even need to put the 1 there, do you? Because it doesn't really make any difference. times the other 4 over 2 times 1. Let's just put it into the calculator. So you can see here it has simplified it for me. I've got minus 3 plus root 5, and obviously the other one would be minus 3 minus root 5, so plus or minus. Now, let's say that you didn't have a calculator. Because you can technically use the quadratic formula without a calculator, the only thing is you won't get, actual decimal answers. They won't make you work out decimals. They'll just say something like this. Let's pretend that this is non-calc. How would I simplify it to get to this answer? Well, let's just go through and work out each piece. So minus 6, can't really do anything with that so far. Plus or minus, 6 squared is 36, and then this bit is 4 times 1 times 4 is minus 16, isn't it? 2 times 1 is 2. Do you see how I can just keep working through it piece by piece? That gives me the root 20 over 2. Now, this is the thing. You can see my answer format doesn't have a fraction, but this one still does. So this is actually where it overlaps, or can overlap a little bit with surds, because I want to simplify this surd. And again, I will link that video down below in the description if you want to go and watch that as well. But very briefly, to simplify a surd, I just need to break it down into 2 factors. One of them has to be a square number. So what square numbers go into 20? Obviously 4. So I can do root 4, root 5. 4 times 5 is 20. And the whole point of that is that obviously then I can square root the 4, can't I? So I get plus or minus 2 root 5 over 2. Now do you see how, looking at all of the terms in my fraction, I have a minus 6, I have a 2 root 5, and I have a 2. All of those, not the root 5, but all of the whole numbers are divisible by 2, aren't they? So that's how I can get rid of my fraction. Divide everything by 2, obviously not the surd, because if you remember surd rules, you can't divide surds by whole numbers. So the surd is still root 5. But minus 6 would become minus 3. Plus or minus, obviously 2 divided by 2 is just 1, isn't it? So that would just be root 5 or 1 root 5, and then the other 2 would cancel. So there's my answer. Do you see how I've got p plus or minus root q? I've got minus 3 plus or minus root 5. So you can also use the quadratic formula for a non-calculated paper if they've asked you to give it in this format. Okay, this question is very similar. The only then difference is that the previous questions were just solve questions. It was quite obvious that you had to solve some kind of quadratic. You also sometimes need to solve quadratics in a different type of question. So in this case, it looks like shapes, doesn't it? Area, shapes. But it will also end up being solving quadratics at the end. I've also seen it a lot with algebraic fractions. When they're in equations, it looks like initially an algebraic fractions question, but in the end, you've got a quadratic to solve. So it can actually be kind of hidden in other questions. So for this one, we've been told that the area of the triangle is 3 centimeters squared. We need to find the value of x, which is another way of saying solve some form of equation. What equation are we going to use? Well, the context is area. So we're going to use area of a triangle to set up an equation and then solve it to find x. Now, they've also then said, same as before, give your answer in the form p plus or minus root q over 2, where p and q are integers. That's another clue as to the fact that, first of all, I know I need to set up an equation, because how can you find x if you don't have an equation? Second of all, I know that the equation that I'm talking about is the area of a triangle. Thirdly, because if you look at the sides, I've got x on both sides. I know, based on area of a triangle, that that's going to end up being a quadratic of some format. So solving it is either factorising or quadratic formula. We're back to this kind of same debate. Then I know, well, it's not factorising because I can't factorise to get this, can I? Factorising is either some kind of whole number or a really nice fraction. So I know, just by kind of scanning this question, I need to set up an equation, it's going to be a quadratic, and I'm going to solve it using quadratic formula, or you could also, as I said, complete the square if you like. So I can pick up on all those details just by looking at the question, and then we'll see how they piece together. So area of a triangle is the context. Area of a triangle is, don't forget, it's half base times height, or base times height over 2. It's not just base times height, right? So don't forget the half. So we got there that we know the area is actually 3, then half. Base is 2x minus 4 times the height, x minus 1. Now you can obviously rearrange this however you like, but we do need to expand everything. So what I would probably do is just multiply across by 2, so that becomes 6, and then I've got rid of the half, and then expand the bracket. So I am just whizzing through this because, the point of this video is not to look at expanding necessarily, but I will link down expanding double brackets as well in the description. Minus 2x minus 4x is minus 6x, and then that becomes plus 4. Now, we said before that to solve quadratics, we need to have everything on one side, so move the 6 across. So we've got 2x squared minus 6x minus 2. Now, you could simplify that if you want. Technically, it's all divisible by 2, but because we're using quadratic formula, I probably wouldn't bother. If I were to factorise, I would probably simplify that first, but I'm not going to. So minus b, this is another one of those examples where the b is already negative. B is minus 6, so I'm subbing in a negative to a negative already. So negative 6, plus minus the square root of b squared, so minus 6 squared technically, minus 4 times a, which is just 2, and then multiplied by c, which is minus 2, over 2a. Now you can sub that all in as it is, or you can simplify it. Again, this may have been a non-calculated question. So again, let's just assume that it is non-calculated just to make sure we know what we're doing. So simplifying it, negative 6 becomes just positive 6, plus or minus. I know that negative 6 squared is just positive 36, and then I've got a double negative there, so plus 4 times 2 times 2 is 16, over 2 times 2, which is 4, and just keep working through it piece by piece. 6 plus or minus, that gives me 52 in the square root over 4. And have a look here. It kind of looks like what we've got here, but the problem is the denominator that they've got is 2, and the denominator that I've got is 4. So I still need to simplify further, and exactly the same as the previous question, it's the third that I need to simplify first. So let's move that over a bit. Simplifying the third, as we said, split it into 2 factors. One has to be a square number, so that's 4 again, and 13. So when I square root that, I get 6 plus or minus 2 root 13 over 4. And now, again, looking at all 3 terms in that fraction, we've got 6, we've got 2 root 13, and we've got 4. All of those are divisible by 2. So 6 divided by 2 is 3. 2 root 13 divided by 2 is just 1 root 13, or just root 13. And then 4 divided by 2 is 2. So do you see how now I've got the exact same format? 3 plus or minus root 13 over 2. So be aware that the quadratic formula could kind of come up in questions that you're not expecting it to. It could be obviously solve this, or it could be a disguised question where you end up with a quadratic and you end up using the quadratic formula. So there's a variety of questions on solving quadratics by using the quadratic formula. As I mentioned, if you want to check out how to solve quadratics by completing the square, I will link it down below. Otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.